Yeah, let me go ahead and talk about this. Okay, so concrete, pictorial, abstract. Math is always taught concretely first. That means the kids are messing with stuff with their hands, touching something, blocks or whatever it may be. Then we move into a pictorial model fairly quickly because it's more efficient. It may look like the concrete model. It may be a little bit more simplified, or doing something like number lines. And then we move into abstract. We tie it to the abstract, which is just working with numbers, okay? Why is this important? Well, because the video that I am going to tackle head on is this little guy right here. So I'm going to call her Tammy because she looks like a Tammy to me. So this video has 14 million views on it, and that frustrates me because that means 14 million views. It's not really 14 million people, but 14 million people are watching this and getting a completely wrong perception on new math. Okay, so what Tammy said, sorry Tammy, I don't know what your name is, but anyways, what she said was that she learned this in her free tutoring session at, I guess it was a math training, and she's saying she's deeming this new math. She's saying the old way that we would have done it, we would have said 43 minus 13, and we would have said 3 minus 3 is 0, and 4 minus 1 is 3. Yay, we got our answer. Okay, so let me go ahead and tackle that straight on. And this is not, let me repeat this, this is not a jab at Tammy or the teachers or anybody else. I'm just hitting this straight on because if I was taught what Tammy was taught, I would be upset too, okay? So this is not a jab at her. That's not my style. But I'm hitting this math on because she was taught this, and this is ridiculous. Okay, this is not new math. So she said 4 minus 1 is 3, then we get 30, and so on. Okay, so here's the problem with this. Even teaching the old school abstract way, 3 minus 3 is 0. This is not 4 minus 1. We call this 40 minus 10. We call it 40 minus 10 because we have to pull out the place value so kids understand when they start getting in regrouping situations why we carry one into the tens place or the hundreds place or whatever it may be, but then we can borrow when we're subtracting or regrouping, whatever you want to call it. And why we have to add 10 when we go this way? Kids don't understand that because we're calling things by its digit name rather than its value, okay? So, but then another thing is, if you've got a kid that's doing 43 minus 13 with a standard algorithm and going through those steps, that right there is a problem. Kids should look at 43 minus 13 and go, it's 30. Because they're doing it mentally. They see that there's nothing happening in one's place, and they're only taking 10 away from 40. 30, I'm done, I've got it. But we can't do that when we're doing all this mess right here, okay? So she's deeming this as new math. This is not new math, this is ridiculous. What she said is that the new math way was supposed to be 43 minus 13. That you start with this 13 and you add 2 to it because you want to get yourself to a friendly number of 15. You want to get yourself to the next 5. Then you start with that 15 and you want to get yourself to the next friendly number, which is 20. So you add 5 and you get yourself to 20. Then you start with that 20, then you add 10 because you want to get yourself to another friendly number, which is 30. Then you start with a 30, then you add 10, then you get yourself to a 40 because that's friendly. And the only thing left that you have to add is 3 because that gets you to the 43 that you started with. Seriously, people, seriously, really? This is nonsense, okay? This was number sense and using friendly numbers, using compatible numbers, turned into a memorized step-by-step algorithm. Abstractly. Crazy. Bad. Not new math. That's very poorly done. It should have been presented on a number line. Now, there's a whole progression with a number line too, okay? Kids start with number pads when they're really, really little. Then they go to a number line that actually has all the numbers written out one by one because your kids are going through developmental stages. They're counting one by one, okay? That's when you see number lines. That's another post I get tagged in. Number lines where it's like 1, 1, 1, 1, 1, 1, 1, 1, 1, 10, 10, 10, and parents are upset about that. Kids who are counters, who count on their fingers like this, we've got to move them into additive thinking. So I'm showing you an open number line, which kids have to be taught how to use. I'm showing you an open number line with a strong additive thinker, okay? So this is what some kids would do, how they would solve that problem. It doesn't matter what the context is of the problem for 43 minus 13. If a child chooses subtraction as their solution process, all they need to know now is like, okay, so now we're getting into manipulate world. Okay, now how am I going to manipulate my numbers? They know with subtraction that they're finding the physical distance between 43 and 13 on a number line. So they plot those endpoints, the 13 and the 43, and they know that they are trying to jump their way to that 43 from 13. Okay, they're going to jump their way. Now, I like to add, so that's why I jump to the right, and I actually use addition to solve the subtraction problem. Some kids, like my daughter, love to jump backwards. That's actually using subtraction, and she's good. I can't do it. I mess it up every single time. Okay, but kids will kind of gravitate towards one or the other. So what happens is you're at a 13. That's pretty ugly. Okay, 13 is not very pretty, but 15 is kind of pretty. So let's go ahead and jump 2. Boom, we're going to jump 2. Yes, that's only one jump, but has a value of 2. I talk about unitizing in my first video. Go check it out. So we've got a jump of 2 to get ourselves to a pretty number of 15. Then some kids might say, well, you know what, that's kind of pretty. I think I'm going to jump 10. So they're going to jump 10, get themselves to a 25. They're getting close, but we still have a little ways to go to get to 43. So then they say, you know what, I think I'm going to jump 10 more. Boom, get themselves to a 35. And then they say, you know what, I can't jump 10. They actually can, but that's another video. I can't jump 10 because it's too much, so I'm just going to jump myself 5 because that'll get me to 40, and that's really pretty. And so then all I have to do is jump 3 more. So this kid chose to go 2, 10, 10, 3, and 5. In order to figure out the distance between 13 and 43, they would just add those guys up. And it's not about lining them up on the side of your paper and adding them up going like this. It's about finding compatible numbers. It's saying, look, I've got a 10 and a 10, that's 20. I don't have to think about that. I see a 3 and a 2, that makes 5. I don't have to think about that either. And that 5 can add to this 5, and then I get 30 because that gives me a 10. Okay, so I've got 10, 10, 5 here, a 5 here, and that's 10. All right, still, yes, this is drawn out. But we've got to place these numbers on a number line so kids have reasonableness. They're able to really figure out how to estimate their numbers and find friendly numbers, okay? This is still pretty drawn out, all right? It turns into something like this. This kid is a really strong additive thinker, and they will say, you know what, I'm at 13, I'm just going to go ahead and jump 10. I don't care that that's an ugly number. I actually can't do that. I have to get myself to a pretty number first. But some kids are like, forget that. I'm doing this with the least amount of steps as possible, and they will go, I'm going to jump 10, boom, get myself to 23. I'm going to jump 10, boom, get myself to 33, and jump 10, boom, get myself to 43. The answer is 30 with 3 easy, simple jumps of 10. All right, but this translates into mental math where they don't have to always write out a standard algorithm, okay? And why is that important? Because whenever your kids get something like this, like 200 minus 97, if they're subtracting across zeros and doing all of this business, that's a problem. Okay, that's a problem whenever you have something as simple as 200 minus 97. If you have a more difficult problem, then sure, yeah, standard algorithms have their place. But something as simple as 200 minus 97, if a kid has been taught to plot numbers on a number line and find the distance between them, they will say, you know what, 97, that's really close to 100. That's only 3 jumps away from 100. And then 100 to 200, that's just 100 right there. That's 100 jumps. The answer is 103. In their head, done. Because they've seen it on a number line. So there is a progression. No, you are not going to have accountants doing new math, counting, drawing number lines and hopping one by one as an adult. Stop being ridiculous. That's not going to happen. This is drawn out. This is all elementary stuff that you're talking about. All these things that I see that I'm posted on Facebook or tagged in on Facebook and wherever, this is all elementary math. We cannot just give kids the shortest, easiest way to do something and have them skip steps. They have to do the steps. They have to work hard to understand why it is that those algorithms work. Okay, so new math is all about efficiency. It's about number sense, making mathematical relationships, algebraic relationships, seeing the inverse relationship between addition, subtraction, multiplication, and division, and meshing all those guys together. Okay, it's really getting to know their numbers. All right, that stuff that all this anti-new math stuff on Facebook and wherever in YouTube, those are every single one of them I've seen is a poorly executed math problem. And it's just given new math a bad name. All right. So you guys subscribe to my YouTube channel. It is Kristina Johnson, Kristina with a K. And then you can go to my Facebook page, which is Mrs. Johnson 333. And you guys subscribe, hit like, and you can follow my parent math video series. That's just getting started. I've already got a couple of things up. And that's to help parents understand, even teachers, understand all this new math and why we're doing it and how to execute it correctly. So anyways, you guys, that's my thing. Again, this is not a jab at teachers. This is not a jab at anybody that posted that stuff. It is just simply me trying to explain how it's actually supposed to be done. All right. So don't let let those posts give you a bad taste in your mouth for new math, especially you new parents whose kids are coming up and starting kindergarten pretty soon. Okay, so let me know if you have any questions or any specific content that you want in a video. Okay.